So running down what different groups are doing, and I'm going to go quickly through this. So NHTSA, these are straight from a NHTSA write-up from TRB. So they're focusing on training, working on operator manual, looking at how to improve enforcement, licensing. They're revising a national agenda on motorcycle safety, talking about helmets, protective clothing, and of course alcohol. Sight distance is a little bit different for them, but they've done some work on trying to look at motorcycle sight distance. And then they're funding the 160 motorcycle study, which I just started last week. We put our first 3 bikes on the road for that study. And then Federal Highway, they're doing a crash causation study, and that's a replica of the HURT study. So that was, in California, motorcycle crashes, send a team to investigate and recreate the crash and understand the causal factors in a post-crash investigation manner. And they're also trying to understand exposure. A lot of question in the states about how much riding is done, and do we measure it well. So they're trying to get a better handle on that. IHS, they pull together all their insurance stats, so they do have property damage to an extent. And one thing they're doing is petitioning NHTSA now that all motorcycles have ABS technology in the states. They focus on motorcycle helmets and injuries. So TRB, now these are a set of research needs statements developed from the motorcycle subcommittee in TRB, Motorcycle and Moped Subcommittee, and those focus on things like licensing. You see here V2V and V2I start to come in, so we've just this year started putting that in the list of things for people to focus on. The others are similar to what you've seen already. So I said there'd be a question, and I want to make sure everybody's awake. So I've covered some of the federal places. Let's talk about the riders. If the riders are answering the question, what's causing crashes, what would the riders say? Anyone? Yeah. But, behavior, and behavior. Okay. I'll buy that. Anybody else? Whose behavior?
Everybody.
Themselves, the other guy?
Most motorcyclists blame the cars.
Cars?
In Sweden, the motorcyclists blame themselves.
Themselves in Sweden. All right. So, in the States, this is me, all the caveats with that, but it's often the other guy, cars and like that. At Virginia Tech, this is what we're doing. So we've got the MSFs I'll talk about. NHTSA, I'll talk briefly about. We are doing connected vehicle HMI work. We're looking at different types of modes of warning for connected vehicle intersection incursion and things like that. Testing those. That's probably will get on the road this spring. We're also looking more at the performance. So a lot of these technologies and antennas have been developed for cars, and so we're starting to look at the performance on bikes. Will they act in the same way as they do on cars? And I'll just call out here. So we kind of think of it in terms of rider behavior, the things we kind of choose to do, and over time, what lane we pick and things like that. And then separately, rider performance and rider capabilities. How hard can we brake? How quickly can we detect a threat? Things like that. So naturalistic research. When I say naturalistic, this is the way the Institute pictures it. Ideally, it's the participant's own vehicle, so it's the motorcycle that they own themselves. No experimenters present. There's no new technology in naturalistic. FOT would introduce maybe a new braking system or warning system, but naturalistic is just put it on the bike they already have, or the car or the truck. And just drive as you normally would, or ride as you normally would for an extended time, months to years. We try to keep the instrumentation unobtrusive, And we do continuous recording, and I'll talk a little bit more about that. So it's not triggered by an event, it's on all the time. So the two studies, there's the MSF 100, and so we finished data collection for that in December, 3 months ago, and are working on papers for that. The 100 car study we did in 2004, and we're still writing papers on that. So in terms of when the project will be done, it'll be decades of work. And then the NHTSA study I mentioned, we just put the first participants on the road last week for another 160 riders. Any way we can. We have lists of owners, and we will send them letters and then follow up with a call. That's the biggest method, the most return. So I'm going to show this big first. This is the biggest you'll see the video. So forward view on top, rider view bottom left, and then split quadrant there. Brake and throttle on the left and clutch on the right, as well as out to the blind spots, and then a rear view bottom right. Give me a second to...
As participants in the MSF 100 motorcyclist naturalistic study start their motorcycles, data acquisition equipment comes to life. Video and sensor data record continuously throughout every ride for 12 months. The sensor suite captures a rich description of the riding environment, as well as precise measurement of rider behaviors and performance. Sensors measure speed, acceleration, location, forward objects and relative speed, yaw, pitch, and roll, and front and rear brake use. Cameras capture a near 360-degree field around the rider, as well as a view of the rider's hands, torso, and head. The data provide a near-perfect witness to what occurs during a critical event. The video views and numeric data provide a description of the riding environment, movements of other vehicles, and even actions of pedestrians. Because the data are collected continuously during every ride, naturalistic data provide lessons from participants who never become a crash statistic and events that are resolved successfully. In this example, the rider detects the deer approaching from the left, effectively brakes, and scans for more deer before continuing on. For those interested in motorcycle safety and transportation, over 500,000 miles.
Little plug there. So that kind of covered the data collection, but here's a little bit more detail. I think everything's probably been covered there. Machine vision lane tracker is really designed for cars, but we're using it on a motorcycle. Here's a little bit of the instrumentation, a little more detail. Cameras of the side and rider, forward radar, the data acquisition system, different vehicle, the rider camera, different vehicle. The idea here is if they're hard to see, they're supposed to be. So as you see that kind of the breadth of the data that we're collecting, I'm hoping that you see kind of the breadth of research questions that it can address. So this pyramid on the left is the way we picture it. The baseline, the reason we collect continuously is so we can understand the frequency. We can have a denominator for these events, whether it's miles, time, or even number of intersections traversed or number of curves at a certain radius, things like that. And then it goes up from there into these rare events like we saw in that video, where we can pick things apart and really understand the sequence and how factors came together in a bad way, or maybe how they ended up getting diverted in a good way. MSF is interested in using it, pretty much any module in their training, and even some that they may not be aware of yet can be influenced by some part of the data set. A little more about the study. 100 bikes were put out, so the percentages are easy. There are 38 touring bikes, 21 sport bikes, and 41 cruisers. In the bottom right there, it shows the engine sizes. So we tried to not only get these different bike classes or categories, we also tried to get different size. So you can see the cruiser sizes went from 250cc up to 1200cc. These are the 4 locations we ran in. Each one gives us a little different climate or straight roads versus curvy roads. In Florida, you don't have to wear a helmet. So we could see different things from each location. I mentioned 100 participants. People sell their bike and move or get sick, so participation ranged from 2 months to 2 years. We did end up with 100 calendar years of participation, which turned out to be these numbers: 569,000 trips, or minutes of riding, sorry, about 38,500 trips, which is starting the bike to turning it off, about 584,000 kilometers of data.